from here, we're going to move forward and actually practice this concept of division using multiplying by the reciprocal as the technique. Okay? And that is listed on page 243. And it's listed as using reciprocals to divide. And you can look at that further at your leisure, using reciprocals to divide. But from here, I want to go ahead and move forward. Now, some things you're going to want to consider, though, folks, is the rules with positive and negative numbers. That continues to be an issue. Positive and negative numbers. Same sign division, so negative divided by negative, positive divided by positive, will always yield a positive result. Even if you do the multiply by the reciprocal, I'm just giving you the result. Whereas different signs will always yield a negative result. This is the rules. They don't change. It is what it is. Okay? If you're struggling with negative, positive manipulation, you need to get that stuff down pat. It's not going away ever. Moving on. Example 1. Example 1 is a simple practice in division where they say, well, what is the result of negative 2/3, and they're writing it this way, divided by negative 5/6. You've already learned that you cannot divide fractions, that you must multiply by the reciprocal. You've been learning that since 5th grade, but we need to put that to practice. The first term, the dividend, does not change. The multiplication symbol, division, becomes multiplication. And the reciprocal of negative 5/6 is still negative, but it is now 6/5. Okay? Reciprocal. Cross cancel where you can. The 3 and the 6 will do the job. 1, 2. Now, real quick. Negative multiplied by negative is what? Positive. Okay? So it looks like our answer is a positive 4/5. Am I right? So even if it's you're multiplying, you can still consider those rules. Example 2. Mixed numbers. Continue to do the improper thing, please. Whoops, that should be a 6. Change them to improper. Negative 6 and 2/3 divided by 1 and 5/9. You must first make them improper, just like we've been doing with multiplication. So 18, 19, 20, negative 20 over 3 divided by 14 over 9. Okay? And then multiply by the reciprocal of the divisor. Remember, the divisor is the second term. Bring down the first term, negative 20 over 3. Change your symbol, multiply. Write the reciprocal, 9/14. By the way, negative, positive, what will the end result be? Negative. Throw your negative out there and then don't worry about it. 3 and 9 reduce by a factor of 3. The 3 becomes, 9 becomes, yep. What do these reduce by? Best case scenario, 2. That's all you got. 7, 10. Did you come up with 30 over 7? Which becomes 4 and 2 sevenths? Do not forget to keep it negative. A lot of you will give me this, simplify it, but forget your negative. Can't do that. Last example, and then we're going to practice some of these together. Chris, I'm sorry, you're going to have to copy it, mixes 2 gallons, otherwise known as 32 cups, of Kool-Aid. Each glass holds 2 1/3 cups of drink. How many glasses can he fill? Okay. Looks to me like I have 32 cups of liquid that are going to be separated into 2 1/3 cup vessels. Would you agree with me? This is a division problem, my friends. 32 cups of liquid divided into vessels, 2 1/3 cups each. Can we do that? Absolutely. 32 over 1 divided by the improper fraction, please. 7/3? Jeez, yuck. Reciprocal? 32 over 1. You never flip the first term. I can't tell you. I know how many of you are still going to do it anyway, but unfortunately, nothing reduces, right? 96 over 7, which is what? 12? 13, is it? Is it 13? It's what?
It's 91.
Okay, so it's 13 in some. So she can fill up 13, not 13 in a fraction. They ask you that. What is the actual fractional result? 96 divided by 7. 13 and 5/7, is it? So they tell you 13 and 5/7, but if you answer the question, how many cups can she fill? The answer is 13. That's how many she's filling. The other one would only go 5/7 of the way. Okay? Which is why 13 is the correct answer, not 13 and 5/7. Okay? Give me one quick second, and I am going to give you the ones I want you to try.